What's up, everybody? Welcome back. Today we are working on our code visualizer, and today's task is adding some 3D rendering to this thing for debug. So for context, this is our code visualizer. He looks kind of wacky when we first start him up, but over time he starts to look a little bit more reasonable. We don't have zoom yet, so I'm actually going to screenshot this and bring it into Paint so that we can zoom in on the parts that we care about right now. But this is him. The idea here is that we take a code base, we represent every file, we take every file, function, type, folder, and we put them as a little white dot on the graph, right? What you are seeing here is that they are kind of like, the dots are moving around in an attempt to kind of cluster themselves based off of a couple criteria. One, what folder / file / type am I enclosed by, right? So a function A that is part of class C should end up like nearby class C, and all of the functions of one class should kind of like end up near each other. The other criteria is what functions call me and who do I call, right? So if two modules interact with each other a lot by calling each other a lot, then those two things should be grouped together as well. And so what's kind of interesting here is we're trying to show two different concepts spatially, which kind of sucks, right? So I want to separate at least a little bit the idea of I'm calling each other or I'm part of this thing. And so that's what these backgrounds are an attempt to do, right? These backgrounds are an attempt to say, hey, this stuff here, all of the stuff backgrounded in green is part of one class. And the stuff backgrounded by blue here is all one file. And the stuff backgrounded in like the darker blue is like the folder that file is in, right? So we can see that like likely in this diagram, it's like kind of hard. We don't have like legends or anything yet, but we could probably guess that like this green section is like a different file than this blue section in this overall blue folder. That's kind of like what we're trying to show here. And so we've been kind of working on this like Voronoi diagram generation as a way to set these backgrounds. Eventually we're going to like focus the backgrounds or the files. We're going to give like a legend and we're going to say like only pay attention to these few nodes because that's what we're working on today. And like we'll automatically select those nodes for focus based off of like how much time we're spending in them in Vim, and we'll show them on the side. And hopefully the overall idea here is that we're hoping to provide at a glance information that shows like in a big project what parts do you need to care about when you're watching today. That's kind of like the overall intent. Today's task is to kind of fix some of this background generation. It looks kind of like whack. Let's see if we can like find an example of where I think it looks like uber fucked. I don't know. There's just some parts where it looks kind of weird. It's hard. I don't know if I have like an exact place in mind, but I think it's like this just feels kind of strange to me, like here. I don't know what's going on here, but it doesn't look right. I'll tell you that much, right? This looks fucked. And I think what's happening, I could be wrong, but I think what's happening is that we are rendering each layer of the hierarchy in individual draw calls, right? So we're kind of saying, take all of the top level folders, render those all at once, and then go up one layer. And the reason that we're doing it, here's it especially, this looks fucked. I don't know, like this, there's no way that's correct. I mean, I could be wrong, but I don't think it is. And so the way we're drawing these backgrounds, we're saying like for each pixel, which node am I closest to? Okay, color me according to that node, right? So we take all of the nodes that are like descendants of one folder, and we put them in one set, and we say all of those are blue now. And then we take we render a Voronoi diagram and say for who am I closest to? Fuck it, I'll be that color. And the way we generate these Voronoi diagrams, first of all, what is a Voronoi diagram? Voronoi diagrams are literally just like, for each point, like which point am I closest to for every pixel, essentially. And the way we generate these things is we actually generate like a bunch of cones. And we say like, for each of these cones will eventually like overlap with each other. And if the cones all have like equivalent slopes, they will overlap each other based off the distance to the center of the cone. So all I have to do is like instantiate a cone at each point on the graph, boom, we've got a thing. Now the problem is if we render in separate layers, if we were to take like, 3 of these guys, duplicate them and move them here, now all of a sudden they don't have the ability to intersect with any of these guys below them, which means that I don't think that we're getting like a correct layout. So what I want to do is I want to basically fold all of the layers into one render, right? So we can say like, instead of doing this point is part of this green set, then we'll render him as part of this blue set, then as part of this red set, then part of this green set. We could kind of do them all at once by doing something like taking the cone and saying like, okay, so the first thing that he's part of is like function F. And function F is part of class C. And class C is in directory D, right? And as you get like farther and farther away, the context where you consider yourself relevant like changes as well. And so the way that we would do that is we would take like a cone segment like this, right? And we would resize parts of it to be like, okay, so we'll take like the outer bit, like basically according to how much we want to show each segment, right? So we kind of take like, how would we show this? We take like the inside. Can I do this? We take the inside and we like scale it down a little bit and like move them up. And then like the bottom side, we take this stuff and we scale this stuff. And we might say like, okay, so now this stuff has to be like wider like this, right? We would kind of like, we want to like control these two rings separately and like kind of stack multiple of these rings together to make one big cone. That's kind of the idea. Now, it would be easy for us to make a mistake doing that, right? Imagine that you take like two cone segments. Maybe we do, hold on. We like duplicate this. And just imagine that we accidentally did this, right? This seems like a very easy mistake to make where like one section accidentally like covers the other one. We don't correctly adjust the like inner ring here to expand it to be the right size, right? That's like a thing that we might do, right? This thing actually has to come like this, and then this outer ring needs to okay, well, whatever, you get the point. This thing needs to get wider as well. And then it's also possible that we like the slopes aren't all consistent, so like maybe parts of the rings are like different slopes from other parts, etc. So we want to like visualize this thing in 3D as we create our like mega cone, just to make sure that we're doing it right. So we actually that's actually the whole reason that we made this GLTF, this visualization here in the first place. So like we made this by basically taking the Voronoi diagram that we generated and exporting a GLTF and importing it into Blender, with the intent of being like, okay, when we make this change, we'll be able to like put it into Blender and then look at it. Great. The problem is that I do not believe that this idea of independently shuffling the top half and the bottom of this half of this thing independently, I do not believe that that is going to work well. Which kind of sucks. Because you need to apply, the GLTF export says, here is an object and here is its transform. And so like, we need to find a 4x4 matrix that like represents like independently maneuvering the top and bottom parts of the ring, which I think is possible with like a perspective transform. This is essentially doing like the exact same thing where you're saying like, as things get far away from us, get smaller, and as things get close to us, get bigger. I'm not gonna look it up right now, but basically like, I can't make that thing work in Blender. In Blender, you can assign arbitrary transforms to objects, but it rejects some of them. And if I try to assign a perspective transform to this thing, it rejects it. So this idea of using Blender to visualize our like complex transformations, I think is a no-go, which means that we go back to the other way. We write a 3D visualizer. We just fucking embed 3D visualizations directly into our app, and then we can make sure that we're rendering our Voronoi diagrams correctly by like maneuvering a camera through the world. We can kind of like fly through the mountains and make sure that everything looks okay. So that's the plan for today. It's also a fun comparison because when we were writing our GLTF exporter, I was kind of saying like, I'm not really convinced this is easier than writing like a proper 3D renderer. And now we get to compare. We get to compare those two things, which is pretty sick. So the plan of action is make a little debug view, add a 3D camera transform, then try to like maneuver the camera in some way, and then try to add some lighting to make sure that we can like see edges of things kind of like correctly. It's kind of, everything looks like really flat and blends together if you don't do that. And then we can try to actually apply our Voronoi fix and see if it looks good. And this is kind of like maybe. We might not get here, but we'll see. We will see. Okay, so let's just get into it. So the first thing that we need to do is I think that we are going to want this visualization to stay here for a long time because it's like kind of like a nice way to show chat what is going on. So I think the first thing we do is we just add a little button somewhere to say, go into this debug view. So somewhere we need some Boolean to track our state. Right? We need like Voronoi debug starts as false. And I think that we want to add this to like, we need to add like a checkbox to our GUI to like turn that thing on and off. So we should be able to do like property list. How do we do this? We have some sort of like label, which is like Voronoi debug label. Let's make a little label that says Voronoi debug. We probably deinit this thing if he fails. Okay, and then we also need to make a checkbox. So checkbox. So here's like make checkbox. Hell yeah, dude. And the checked status is going to come from Voronoi debug boolean. And on change, we're going to do something, which I think is going to be some UI action that's like toggle Voronoi debug, I think is what's going to happen. So what's going to happen is our like debug, our GUI framework is going to say, hey, the user clicked something, and we're going to ask you to do that thing. But like you could choose not to do it if you didn't want to, you know? If you felt like it, you could. So let's do toggle Voronoi debug here. Boom. And then we just add this thing to our property list. So we say property list at push widgets. Here we go. And Voronoi debug label, Voronoi debug checkbox. Boom. So that should do what we want, I think. We could just kind of, I guess we also have to like apply the action. So toggle Voronoi debug, we'll just say Voronoi debug is equal to not Voronoi debug. Boom. Teach, thank you for the raid. What's up, everybody? What is up? Let's quickly try to show you guys what we're working on. Apologies to people who just got the rundown. We'll give a bridge version. We'll give a bridge version, but this is our code visualizer. The idea of this project, give them a sec to like fix the graphical glitches, but the idea of this project is that, you know, we're working on a big code base. We want to represent what we are working on like right now. So, you know, maybe we're working on like the text renderer shown in red, and we want to show all of the parts of the code base that he like relates to, right? The idea, we're going to try to show like more relevant info in some way, try to focus the graph a little bit more, but right now we're just playing around with like different visualization strategies, etc. What we are working on today is trying to clean up some of these backgrounds. So these backgrounds are representing what folder, what file, what type I'm part of. These are generated by making Voronoi diagrams with kind of like thresholds on the maximum distance that we can come from. Voronoi diagrams basically say for each pixel, how close am I to any given point, which point am I closest to, and what color is that point, essentially. We do that by making some cones. We put cones on a page. Cone, if you have like two cones next to each other, eventually they will intersect each other. And so just if you look from like straight down on top, which cone do you hit is which cone you are, which color you are, essentially. We're working on fixing we're rendering these things in layers. Layers bad because cones can't intersect if some cones are below other cones. So we're trying to basically say each thing is part of a file function, then part of a class, then part of a directory. And so we're kind of trying to merge all those concepts into one cone, writing a 3D renderer to validate those are correct. Boom, boom, boom. Sorry for the quick, maybe not so great explanation, but I just gave it to the people that were already here, and I don't want to waste too much of their time. So thank you for the raid, Tej. If you guys want to stick around, stick around. But if you don't, no worries. Thanks for the raid. Okay. So let's get stash pop here. And we were just adding a checkbox to our debug view. So this thing is supposed to say, make me a checkbox based off this thing. And he's complaining because the checkbox in our GUI framework expects some sort of behavior. It looks like he is calling get checked, who says, am I a structure? If I'm a structure, call the checked function. Otherwise, checked retriever here is a better error for this. Otherwise, if I'm a pointer to a Boolean, just fucking look at that Boolean. Oh, and I'm an array. This is wrong. This is supposed to be single one. Yeah, okay, so that should make this work. If I'm a pointer to a Boolean, use that fucker. Expected type bool found pointer to bool, so we need to double dereference this thing, because it's a pointer to a pointer, get fucked. And now we should be able to click this button, checkbox shows up, bing, bang, boom. Okay, so now we can use this to decide whether or not we're gonna do the 3D visualization or the 2D visualization. Okay. Add debug checkbox. Boom. Huge. Done. Okay. 15 minutes. Add a 3D camera transform. Okay. So all of our like code right now, all of our OpenGL code kind of like originated in our image editor project, and our image editor project was like super 2D. So we might have to add some types to work with like 3D transforms and stuff. But I think overall it shouldn't be too bad. Let's do something like this. We're going to have some sort of camera. And the camera, I guess, is going to have some sort of movement based off of like input from the windowing system, right? So we're probably going to have what? A function to like make transform, i.e. like a way to transform points from like world space into like the viewport, the view of the camera, right? For those of you who haven't done a ton of 3D programming, basically like you can imagine like there's a camera here, he's pointing at this cube. If I'm the cube, my cube has like points that are defined like in the world, and the camera is like somewhere else in the world. And so if we want to like convert these points into like the viewpoint from the camera, you do that through this thing called like a transform. You basically have like a matrix that you take the points of the cube, you multiply them by the matrix, outcome points from the perspective of the camera. So this should probably return like some sort of like 4x4 matrix, probably. Which means that we probably need to like import our math library, which I believe only has 3x3 matrices right now because of the because we were only working with 2D transforms before. So let's just copy our mat 3x3, turn them into a mat 4x4. Mat 4x4s need probably what, 16 floats instead of 9, 4 squared. We add some zeros to the end of here on our default transform. The identity matrix has like ones on the diagonal, zeros everywhere else. So this does nothing. Our matrix multiplication, all of these threes need to turn into fours. All multiples of threes need to turn into multiples of fours. So probably 12 here. We probably need a W component in our 4-dimensional vector now. So this thing needs to go from 12 to 16. This is clearly heavily fucking duplicated with the 3x3 case, so we should probably do some sort of like deduplication here later. But for now, let's just kind of work with what we got. Matrix multiplication. So this is mat 4x4 by mat 4x4 gives us a mat 4x4. Actually, on these things, all of these things need to be 4x4s and vec4s as well. Okay. And again, this is going to look very similar. We're going to have 16 floats instead of 9. We're going to iterate by 16s. Our rows are determined by divisions by 4. Our columns are modulo 4. Our rows are coming from this row times 4 to the end of the row times 4. This turns us 4 floats that are offset by 4, 8, and 12, probably. This is really like, I'm kind of just like pattern matching here. I'm actually like very unsure about this math, but we will write a couple tests just to make sure it's correct. Inverting a 4x4 matrix I think is way harder than doing a 3x3, so I'm just going to delete that shit. Transpose, I don't think we need that right now, so I'm just going to delete it. And we have our fucking 4x4 matrix, baby. I feel like he's going to die. How does he not run out of oxygen because I don't take any breaths? Okay. So can we just write like a quick like sanity matmul here? Sanity mat 4x4 mul. So I guess, can we just like, do we have Python and NumPy? That's the easiest way to test this, I think. Python 3, import NumPy. No. Nix shell, Python 3 packages NumPy. Give me that shit, please, sir. Sir, I would love some NumPy. Okay. Import NumPy. There we go. And so we can go like, let's just do, can we do like rand? Does that random? Can I do random with like a shape? Can I like, I don't remember how to do this. NumPy random matrix. Rand with a given shape. So if I want 4x4, then I type NumPy random rand 4, 4. Boom. A is equal to this. B is another random one, and we do A, B. This is our output. Oops, I should probably do get A and B as well. Okay, so we'll just copy paste these fuckers into our test and make sure that we get the same answers. Boom. Okay. So this is A, this is B. How do we like initialize these matrices? We literally just like huck in data, I guess. So these are probably row column. Boom, 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 boom. And then I guess we just delete these. Boom, 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 boom. That looks kind of like a matrix to me. Sure. There's our A matrix. B matrix is this. This thing needs a dot in front of it because we're writing zig. And this stuff goes here. Boom, 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 boom. Delete till the bracket. Go shift me back, sir. Delete this. We probably want like a comma at the end of these. Okay, so comma, delete the square brackets, and to the right. Bang, bang, boom. And then we have our expected. Okay. Const expected is a mat 4x4. Boom, 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 boom. Data equal to data. Boom, boom. I probably could have macroed this, but I'm not smart enough. We didn't think about that ahead of time. But that's okay. We'll live. All right. Seems chill to me. Okay, so now we should be able to like stood testing expect approximate equals. It looks like this probably is done on floats. Any type? Maybe this works. Can we do like expected data is approximately equal to a matmul b? I think that this is, we do this right to left. I'm assuming we do A is row, B is columns. Yeah, so that's right to left. Okay. And then tolerance like 1e -7 or something. Like fuck it. Can we go into the math library? Zig build test? Question mark. We'll just kind of see if he succeeds. He's unhappy because incompatible types 16 F32 and mat 4x4. So here I think we need to do data here. On incompatible types 16 F32 and float. Oh, does the tolerance have to be the same? He also just doesn't work here. Okay, sure. So we actually want to go like output is a mat ball like this, and I guess we go like for expected data, output data, AB. We do an expect equal of A and B. Like this. I guess expected val and output val are more clear. Expected val, output val, boom. All right. Fuck. Try. Okay. So now he's mad about these things not being within tolerance, but those numbers are quite close, right? We have 1024193, 1024194. So I think that we just reduce the tolerance here. 1e -4 is probably good enough. Okay. Hell yes, dude. We fucking wrote our matrix multiplication correctly. That's huge for us. Absolutely mega big, huge big. Okay. So now our camera can now work with 4x4s. Hell yeah. And I don't know what we're gonna do with that. But just raw dog that shit in like 4 minutes. Well, I mean, we were like copy pasting from the mat 3x3, so it wasn't that hard. It was just you know, a little bit of 3s to 4s. It was just lucky that we didn't fuck anything up because it would have taken a long time to debug. Okay, so we're gonna have some sort of like transform that takes in camera. We need a type of camera. And what's he gonna do? What's he gonna do? Who knows? We are either going to like generate this transform on the fly, or we're going to hold it forever inside of us and adjust the transform based off of user inputs. That's probably easier. Yeah, that's probably easier. So I'm in the air. I'm looking down. I'm a camera, right? I'm looking down, and somebody says like move. We can just take the existing transform and move. I guess if they say like move left, we move along the axis that the camera is already pointing, like this. If they say like move forward, then we have to move like this way. Yeah, so we take like the, I guess we just store the transform here. And in reality, in our math library for transforms in 2D, we had like a wrapper type around this thing that made it easier to work with. I think that I probably want to give the same treatment to the fucking 3D transform. So we'll call this transform 3D for now. And he has like a nice little helper type that says then. So you do A, then B is just like the matmul in the other direction. Okay. Apply, we probably don't need this. Invert, we probably don't need this. Scale, so scale is an easy transform to make, so we'll just make this now. It's literally just X, Y, Z along the diagonal for the scale. All of these guys stay constant, and then we get a 0, 0, 0, 1 on the bottom. Boom. Okay, so that's the scale. Rotate A to B, I'm also not going to do that. That sounds difficult. Rotate, we probably need to like pick an axis to rotate around. So I'm not going to think about that yet. Let's just do translation now. Translation is easy. Very easy. So translation is literally just the rightmost column of this thing is what we care about. So we get X, Y, Z here, and then diagonals are 1.0. Boom. Okay, so that's our like translation transform. Boom, boom. Okay, so there's our scale, here's our translation, and then let's start with doing like camera translations, I guess. Oh, hold on. We also need like perspective, right? Okay, we'll start with like literally just doing like I guess we might not even need a camera type. We might just be able to hold the fucking transform and just apply normal matrix math to it. It might be that like adding a camera type gives us literally no value here. So let's start there, and we'll add a camera type if we need to. How about that? How about that? So I guess here we'll have some sort of like Voronoi camera is going to be a math transform 3D. Okay. And when the debug is toggled, I think that we reset the camera to be kind of like its default. I think that makes sense. Okay, then we're going to have to like do something with that camera. Surely. So we're gonna have to like handle inputs somehow. So here I think we're gonna go like, if we are in Voronoi debug mode, we're going to like apply movements to the camera based off of what was like clicked, which buttons were clicked. So we're gonna like walk our input state, which I think is in like our GUI, like there's like GUI runner input state. Yeah. The keys are press this frame. And I think we just say like, if we have some key and we switch on the key probably. What is this thing? A frame key is a key event, and this is a union enum. So is key down like the key was pressed right now or that the key is down right now. I don't know if we handle like holding the button at all. So that's kind of interesting. Let's look here. We can look in our like windowing abstraction and see how he sets the key down. So it's key callback. He has a key callback that says, I pressed the key this frame. Gross. Which means here we're going to need to like handle key up events. Surely our thing needs to add key up events for this to work. Or we just bypass this completely. Is that something we can do? GLW is key pressed. Can we just pull for the keys right now so I don't have to think about it? There's key callback, yes, but can I just say like, aha. Yeah. Let's just do that. So here, can we just call like, oh god damn it. Okay. In our GLW abstraction, we're gonna say like pub function is key down. We're gonna be like take in the key code. And I guess we're gonna do like the inverse translation here. So we're gonna say switch key if the key is between A to Z. He doesn't like this. Oh, triple dots maybe? Yeah, there we go. We say, I guess it's like GLW key A plus key? Yeah. Yeah. So this is the GLW key, and then we can call return whatever the fuck they said. And this will tell us if it's press, we want press or repeat. We'll call it state here. And we return the state is equal to repeat or it's equal to GLW press. Was it equal to or mask? Is one of these. Okay, yeah. Okay. So let's just start there. Sure. So let's just say like I think this thing was what we're doing, we were just saying like std debug print W down is this, which just comes from GFW is key down W. Let's just see if this does what we want it to do. My body is ready for Svengen. Hell yeah, dude. So are we finally making games or something that just smells like a game? I guess just something that smells like a game. GFW key is mad because is key down. This thing probably expects the window. Yeah, so here we need like self window here, probably. This is, we're on our like 50th stream of like working on this Voronoi diagram. W is down, false. This is not working. It is always false, which is not good. Which is not good. Can we check? Got key this. Let's just start there. Are we at least seeing like press this. He is saying got key W, which is good, but he does not think W is down, which is not good. Okay, which means that GLTF get key is not working correctly. The function returns the last state of the specified key to the specified window. Desired keyboard key or GLTF key unknown. Which is GLTF. What happens if I just like hard code key W? Like, am I fucking stupid? Oh, that's working? We're getting true and false there. So then that means that the mistake is this, because it's plus A minus key. I'm a dumbass, that's why. Oh, key minus A, you're right, that's backwards. You are correct. I will say that I did get there just in time, but you did say it before I said it. Boom, boom, boom. Okay, cool. So now we can check if the camera's down, and for each frame that the camera is down, because we're not going to be very smart, we could do like movement times equals delta. Fine, fine, we will, fine, fine. Last frame time is stood time instant now. You guys have convinced me. You guys have convinced me that we might as well fucking do it right. Then at the beginning of the frame, we get what now is. Okay, and then we say last frame time is now. This thing is variable, hell yeah. And then we say that the frame delta is now since last frame time, and this is in nanoseconds. So can we just do like delta in seconds is a float from int of this thing, and then we like divide equals by ns per second. Nice. Fine, fine, fine. Okay. So now we can apply some movement to our camera. So our camera, we said our Voronoi camera is just a transform 3D. So we should just be able to be like, do whatever your existing transform was, right? We take your existing transform. So Voronoi camera, Jesus Christ, fucking autocomplete. Voronoi camera is equal to the existing camera transform, then a transform 3D translation of some movement along the z-axis. So it's like 0 x movement, 0 y movement, and some movement along z. Maybe z is the worst one to do first. I think we actually want to do A and D first for sideways. I guess W, A as D, we could make them go perpendicular to the camera or something. Oh, fuck it. We'll just do A and D first. We'll do A and D first. So, is left, like, I guess we'll say like X movement is equal to 0. And then we'll say if is key down A, X movement minus equals, you know, some sort of like move speed is probably going to be something like 0.1 per second. Maybe that's a little slow. 0.1 per second is probably fine. Then we do this as like equals minus equals move speed times delta seconds. There we go. And then if we have D, this is plus equals, then we get an X movement on the camera. Okay. And then can we print the camera? Yeah. I guess we'll print it. I don't know, man. Voronoi camera inner data or something. we're just hoping to see the number move. We're just hoping to see the number move a little bit. Cannot specify without a format specifier. Okay, any. Okay, turn on debug. And we are seeing that like, as I'm pressing D, this number gets big. And I press A, it gets smaller. So looking good, looking good. Okay, so now what? Let's start with this, and I think we're gonna render the Voronoi stuff, and then immediately say if Voronoi debug continue, because nothing else is going to support this stuff. So I guess we are actually going, if we're gonna do early exit here, we need to make sure that our like end of frame stuff gets done no matter what. So that kind of means that like all of this like last frame, like end of frame stuff, kind of just needs to be like in a defer block here. Right? Just to make sure that it fucking happens. Performance got significantly better since yesterday. What was a bottleneck? I missed a major part of stream. The only real problem was that we were discarding in our fragment shader, which caused the early depth tests to get disabled. Everything else that we were looking at was like RenderDoc was just kind of over-reporting our frame times, which we didn't understand at the time. But the early depth test thing was like a real fix. And I guess we probably also want to do like, oh yeah, that's probably fine. Okay. Oh shit, we don't. I guess we do still want to render the GUI, huh? Okay. So we're gonna undo this defer change, and instead, what we're gonna do is we're just gonna put like literally everything under if not Voronoi debug. All of, I guess, like the rest of the rendering. So the node buffer and the line buffer. It's literally just this actually. Smath points. What is this for? This is literally not used. So I don't know why we're doing that. Okay, so now we can turn this on. Points go away. Turn this off. Looking decent. Okay, cool. So now RenderDoc has been awfully used with my window manager, so I have to use NVGFX. Yeah, I don't have an NVIDIA card though, so I'm fucked. I was trying to use AMD's profiler, but it didn't work on NICs, so I had to give up. It was a hard life. Hard life. Okay, so I guess we have to render with some form of camera transform, right? That seems like the option here. And surely we just have to set a uniform somewhere. So in our vertex shader, we must have to take in like uniform matte 4x4 transform. And can we just apply that transform here? Question mark? Seems pretty reasonable to me. Everything else is just passing on to the fragment shader for like coloring and stuff, which should all be done from the perspective of the top of the world. So I think that's probably fine. Later, we might end up having to do some like lighting calculations in the fragment shader, but for now, I think this should be fine. And so all we should have to do is like be like GL get uniform location given our program. We could probably stash this thing, but I don't give a fuck right now. Uniform lock is this, and then we say GL uniform. How do I upload like a 4x4 matrix? GL uniform matte. One of these. Oh, matrix. Surely just the default matrix 4. These should be one. Oh, let's count. Okay. The number 4 indicates a 4x4 matrix. Yeah, so we say, was it GL uniform matrix 4? And then there's FV and DV. What does F and D mean again in these? D is probably double question mark. This doesn't even talk about the D versions in here. So let's see what the F. Okay. The F here means floating point, I is integer, UI are unsigned integers. Okay. Then what does the V mean? Or a uniform variable array. So like, right, okay. So here we're saying like edit an array of 4x4 matrices at this location, and they're just saying like count, we only have one to modify because our matrix size is 1. Our transpose, we do want to transform because OpenGL stores its shit as column major, we store our shit as row major, and then we should just be able to be like, here's our transform. Here you go. There you go, buddy. And I guess let's just see if the things start moving if we start hitting the camera. Yeah. Oops. Like this, I guess. Okay, and then Voronoi Viz is like mad, so can we just be like, somebody else is trying to use this thing and he's like, please give me your transform. We're like, we don't fucking have one, bitch. There we go. Okay, so we go into debug mode and that is working. It's moving very slow, but we are seeing some movement here. Let's like crank up the speed a little bit. So let's crank this up to like 5x maybe. Okay, go to debug. Okay. We could actually even go even higher, to be honest. We go 1.0. And then we need to look for... okay. I guess we need some sort of like movement in the z-axis as well. We need some rotation as well. So how do we do that? We're gonna want to rotate the camera probably by like clicking on the screen and dragging, I guess is probably what we're gonna do for now. So if we drag up, hold on. If we drag, we're looking here, we click here and drag up. We probably want the camera to like rotate in that direction. We'll kind of treat it like a, as if when you're clicking, you're playing like a first person shooter, which means that we're kind of rotating the whole camera. If the camera's like here looking out, we want to rotate them up like this, which means that we're rotating through like a bar this way. So I guess we need to write down where the mouse was clicked. Probably. So surely there's some sort of like GLW is mouse down. Mouse input. Get cursor pause. And then can we like check if the mouse is down? Mouse button input. Get mouse button. Okay. Is mouse down? Oh, wait. Hold on. Our input state is actually like really well suited for this already, actually. So the reason that we were using GLW directly here is because we didn't handle like repeat events and like held mouse key presses, but we do support held mouse presses. So we should be able to be like mouse down location. If there is a mouse down location at block, we can find where our X and Y rotations. Is that how this works? If I drag my mouse like this, does that mean we want this much X rotation and this much Y rotation? Or this much Y and this much X? I think so. So we can probably just take like the individual components of that thing. Okay. So what? We take the current mouse location. Mouse pause. So we'll say like pause is this, pause minus down lock, pause X minus down lock X. This is the like Y rotation, Z rotation around the Z rotation axis. This needs to be like times rotation speed times delta, probably, right? And we want to have like a rotation speed. For now, we'll just have this at 1.0, and then the X rotation is for the Y values. And then we just apply these guys like this. So we say the camera is then a rotate, and we need to pick around, like, rotate around. I guess we do each of these separately. So rotate Z, we'll call this by Z rot. Okay, sure. And then we'll do rotate X around X rod. Boom. Seems pretty straightforward. Maybe I'm thinking about Y up. Yeah, I think that we have Z up. Oh, wait, we have Y up. I'm confused. Yeah, I think we are Y up. You're right. Which means that we want to rotate around Y here, not Z. You're right. I forgot. I was thinking about Blender coordinate system, not our coordinate system. Okay, so now we just need to figure these things out. I think that this isn't quite correct, by the way. I think that there are like some slight issues with this, but it'll be good enough for us to be able to just move around. So we need to write something. And so we just take the 2D rotation function and make sure that it's going around the right axis, which is kind of fun. Right, so we take this thing, whomp, and if we're rotating around X, then that means that X is not moving, which means that X needs to be 1.0, which means that all of this stuff is happening in the bottom right corner. It has to be. So this stuff comes down like this, I think. This comes here. Okay, so this is 1, 0, 0. Then this still happens here. Then this is also 0.0 because it's a 4x4 matrix. Then we have 0 here, here, and here. I think that's right, because if we're rotating around X, it's only Y and Z moving, yes. And then the rotate around Y means that we need to change it so that Y doesn't move. So this becomes C. This becomes 1.0. Then the things need to line up, so this becomes negative S here. Then this becomes S here. I think it's like this. I'm not like 100%, but that feels kind of right. Right? The y-axis doesn't move. We have cosine, negative sine, sine, cosine, and the y position doesn't change. Only x and z change. Yeah, that seems right. That seems right. Okay, so we go into debug mode and we click and drag. Okay, so we need to it's behaving like a joystick, which is bad. We need to like kind of stash the initial location, I think. Or just take like this frame's mouse movement, which we don't keep track of. So, sorry, I'm just thinking. I think we also need to be careful about like the order that this stuff is happening in. So if I think it's like I move the camera to wherever I was, then I rotate more. Yeah, so it does go that direction. Okay. So I think we just say if we have the down location and our position. I think that we just want to... I think we just want, like, to keep the last frame's mouse position instead of doing this. So we'll say, like, last mouse pause equal pause, which means that we need to, like, last mouse pause is going to be, like, a vec2. Or maybe it's going to be a mouse pause. Okay. I think this thing has to be optional, actually. And we'll say if the mouse went down, we'll say if if last mouse pause equal to null, we set the last mouse pause to the current mouse position or the down location, and then break out of this block. And then else we need to say last mouse pause is back to null. And then instead of moving relative to the last down location, we moved relative to last mouse pause like this. That seems reasonable to me. Okay. Debug. Okay, so that's kind of working the way I would expect. What about this? It's hard to tell when I think this is right. Sometimes it feels like it's going backwards. I can't really place it. I'm really struggling to place it. Someone's saying that my Y rotation is wrong, which might explain why it feels wrong. The negative sign is the one on the third row, first column. Why would it be different? I'm not convinced. I'm not convinced it's wrong. I guess maybe it'll make more sense when we add perspective. I'm kind of surprised this is working as well as it's working. Oh, I guess, okay, this is going that way and this is going that way. Yeah, I guess the Y does feel inverted. I'll give that to you. The Y does feel inverted. I'm more convinced now. I actually just maybe can't tell, to be honest. No, it was actually the other way felt inverted, actually. But maybe it's because my X and Y are just kind of in the wrong order. I'm just going to leave it the way it is. Fuck it. Fuck it. I'm not going to think about it. We'll leave it like this. And let's get perspective working. And then once we have perspective, then we can think about it a little more. So can we add, like, perspective? By eye, it looks about right for what's worth. Yeah, I can't really... I think I'm having trouble telling because I think up and down look the same because of the, like, orthographic projection. So I think this will help. Okay. So, perspective. I'm just going to look up... Okay, so I look up this to find this thing. If you look up graphics pipeline on Wikipedia, they will tell you the camera transformation in here somewhere. Here, this is what I'm looking for. Is there like infinite perspective? This is here. Near mouse far. I know that somewhere they list the infinite perspective matrix. Oh, this is parallel projection. Maybe they don't list it here. It's fine. We'll just use this. So Boom. Okay. So these should be all 0, 0, 0. They're using -1 here. We've derived this many times ourselves, so I'm kind of willing to be a little bit cheeky here. We need field of view here. So the H is cotangent field of view over 2. That makes sense. Which I think is the same as... I can never fucking remember. Is cotangent the same as acos? I think it is. I'm just I'm gonna assume square projection for square world for now. That's easier. And then we need const f, I guess here. We need far, near, okay, and then the we'll just call this like, I don't know. Z1 is far over far minus near, or near minus far. We have to be careful about like direction of this thing. These, we need to check if they're projecting so that like closer things are closer or closer things are farther. You know what I mean? Like the number could go up or it could go down. It really depends on what their convention is here. So we do have to pay attention to that. But we'll just do this for now and see what happens. Okay, so let's apply this perspective. So I think we want to apply perspective after the camera movement, right? So I think that we actually want to treat the camera transform normally and then maybe do the movement then a perspective thing when we actually do the render. That's kind of my guess. So we probably want to do like then math transform 3D perspective with like a field of view of stood math pi over 2 for 90 degrees. Right? Yeah. And then near plane of like 0.1 and far plane of like 2.0. It doesn't really matter too much here. That should be good enough. Okay, so first of all, this is mad. If Voronoi debug, we do this. Else we do this. Then we do transform here. He's pissed because what? We forgot a bracket here. We need to specify transform 3D here. Okay, so this should fix the non-debug case. Okay, but then we click this and it just gets like totally fucking busted. Probably because the transform is fucking wrong. Right? If I had to guess. Do we not want tan instead of acos? That sounds kind of right. I think that I did just fuck that up. Yeah, because they did say... I didn't really think about this. Yeah, cot is just... I was seeing the CO, so I thought cos. But yeah, I do feel like this is... What is cotangent again? Cotangent. Cotangent A... So this is just inverse tangent, right? So this is just wait. Cotangent was one of the 6. Sine, cosine, sec, oh god damn it. So is this just like the fancy math people way of saying tangent is opposite over adjacent? Yeah, so what do I think? I think tan x is equal to opposite over adjacent. And so if we're trying to go from angle to like something, what is this supposed to be doing? This is saying like at z 1.0, how far away should things on my y-axis be, which are a function of half the angle? So the y value times something. What if we just wrote some ones in here? What if we just wrote 1.0? Let's just out of curiosity. He's still mad. What if we did cotangent theta is 1 over tan theta? That makes sense. That makes sense. If you say so. That seems more reasonable to me. That's some fucking English I can understand, baby. I still think this won't work because I suspect that they're expecting our depth test to be in like the opposite direction. We're probably, what are we using? We're saying that as the number gets bigger, things are farther away. And so let's just plug a big number into here and see what happens. So we should be seeing so as z gets big here, it gets multiplied by far over near minus far. Then the divider gets bigger as z gets bigger. Z times this thing. So this is getting bigger as z gets bigger, which means that the thing is shrinking more, which I think makes sense. Can we plug in like can we get like numpy here? Hello? Oh, Python 3 packages, numpy. We forgot dash p. Could you imagine create a quantum emulator? What does that even mean? Okay, so let's just say that we have this perspective matrix. So we have like FOV is equal to import math. FOV is equal to math pi over 2. Okay, then we say that we have 1 over math tan FOV over 2 is 1. Okay, so that's kind of good because that kind of matches up with what we were doing, what I wanted to do anyways. So we have a numpy array of like the first row 1 0 0 0, second row 0 1 0 0, third row, what did we say? It was like 0 0 z1 negative 1, and the fourth row was 0 0 z2 0 or something. This is gonna get mad because those don't exist. But that's okay, we'll get there. Why is he pissed? Oh, because I forgot a comma. Fine, you say so. Z1 is not fine. Okay, so we defined Z1 is equal to like 3 over 0.1 minus 3, right? That's what we said. And then Z2 is like 3 times 0.1 over 0.1 minus 3. Okay, so then we can make this. Okay, and we can do like, can we just say like mat times 0 0 1 1, right? So something that's like 1 meter away. Then if we go like 2 meters away, the number is getting smaller? Question mark. Okay, so A is this, B is this, and then we have to do like A2 over A3 and B2 over B3. So the number is getting smaller as it gets farther away, which is not what we want. We want the number to get bigger as it gets farther away, or we need to invert our cone, which is annoying. which is annoying. I think that you just have to like invert something here. Can we look up like perspective matrix GL greater? Perspective matrix, right? I'm not high, right? We are like node Voronoi. I think I'm not high. Gen cone vertices. I'm pretty sure we have it so that like the height here gets applied as the z component of this thing. The height is 1.0. Yeah, so I'm pretty sure we're going like 0 to 1. Which means that, I mean, do we like depth func anywhere? Just we're not using this. What's like default, like the default GL depth func? I assume, what is it? Is it greater or less? Default GL depth func. You might want to do the W normalization. I think I did that part. I think I did. That's what I did here. I think. Right, so we did increased Z value, gave us smaller normalized values. I think. My bad. Oh, no worries. I think that I did it pretty quick. So it's... I'm pretty sure we're using GL grader, but we should double check that. So can we do like GL get, I think is how you do this? Depth func. And can we like get, is this like an integer? Std debug print depth func is this. Like this. All right. Uh, 201. So can we look at like 201 in here? Less. Okay. So the default is less. And the depth func is passes if the incoming depth value is less than the stored value. Yeah, so we're saying the things that are farther away need to be bigger because this needs to pass. I assume pass means that the pixel is drawn. I assume. I think that we could maybe set the depth func to GL always just to like see if this is in fact the problem. Which it in fact seems to maybe not be. Because it's still totally fucking black when we do that. That's kind of interesting. That's not what I was expecting, actually. That's actually not at all what I was expecting, which means that I must be misdiagnosing the problem. I must be misdiagnosing the problem. Okay, hold on. God damn it, dude. God damn. Am I just doing something like fucking brain dead stupid? Graphics pipeline. Perspective. Far? Oh. I did far near in my function inputs. instead of near far. I mean, that's still not helping, surprisingly. Far, okay. Far over near minus far, okay. Near times far over near minus far, okay. -1, -1, okay. What am I doing stupid wrong? Can we go back to turning that GL? So what's kind of interesting here? I guess we should double check actually that this is being applied correctly. So we have the things positioned in the world multiplied with the transform. Yeah, I don't see how that could be really that wrong. And if we did something like silly, like instead of doing this, could we apply like a scale or something instead, just to prove to myself that like I know that this is behaving the way I want it to behave? That'd be kind of interesting. So like, what if we just did something that was like, okay, comment this out. I guess we'll just say like, if true, can we return something else? Just to prove to myself that I understand how this works. So if we were to just say, first of all, 1.0, give us full identity everywhere. Okay. This should be fine, right? Nothing should go crazy wrong here. This should just look like the way it was before. Cool. Okay, so now let's try doing something like 0.5 on the W value, which should make everything small. Oh, but maybe it's like kind of small unconditionally, so maybe that's wrong. So maybe let's say that like, let's scale everything by 0.5 here, which should make everything kind of jump inwards here. Okay, right, so this transform is like clearly being applied at least to some extent, okay? So now can we do something like scale us with Z? Get smaller as you get farther. Okay, that's starting to like fall the fuck over. And why is that? Oh, because we're supposed to do like near minus far shit. Oh, we're out of the near plane. I understand. I understand. We're out of the near plane is negative because we're in like OpenGL space. So our camera, what if we just make our camera a little bit farther back? Because the whole world is at 0 and we're saying that our minimum value is 0.1. So that's probably it. So can we just set our camera transform to be at initial value of -1? Yeah. Math, transform 3D, translate, 0.0, 0.0, -1.0. That should fix this, I think. It was just the near plane was like, yep, there we go. Okay, so that's something. It's obviously not great, but at least it's not just like uber fucked now. At least it's not just uber fucked. So let's just go backwards even farther. Let's make it so that our A and our W and D keys move forward and back. How about that? How about that? So W and S do Z movement increase and decrease, and then we apply this to the Z movement here. So now can we like move backwards? turn this on. Move backwards, forwards. Something's wrong. Okay. What if we increase our field of view here? Oh, yeah. No, math.py is like 180-degree field of view, right? That's insane. Dude, I hate everything. So just to double check, this is far, near. 10 is my max. Near is 0.01. Okay. So I don't really understand why this thing is just like fully disappearing at any point. Right, we go back here. Here we're seeing like yeah, we shouldn't be that far. Something's wrong. Something's wrong. I just can't place it. I can't place it. Oh, this is supposed to be like, this is not supposed to be that hard. This is not supposed to be that hard. This is pissing me off. Let's go back to this, where we say, fuck FOV. So here, my numbers are not changing by very much. I'm seeing like, if I'm at -1 versus -1.01, shit's like really changing. Okay. Let's just be very clear here. Z1 is far over near minus far. Near times far over near minus far and -1. Oh, I fucking hate everything, dude. I hate everything. Does this like the same answer that other people get? He got perspective matrix with field of view. So he gets, these are the like XY scalars. 10 is negative back plus front over back minus front. Which is not the same. He's getting something else. Dude, I fucking hate that this takes me so long every time. He's got negatives on both of these. Which is, again, just different than what Wikipedia said. Oh, but he has far minus near on the bottom, so the negatives cancel out. Ugh. Yeah, so here he's saying, I don't understand. I don't really understand how this could be so bad. It seems like we're really not doing a ton here. So maybe we just have to punch in some values here and see if they're wrong. So we punch in a Z, which we did. We did this in Python land. So like Z value of all of our cones should be in the values of like 1 to 2 essentially. What if, okay, let's just, can we go back into our Voronoi render and turn on always here, just for some clues again. Yeah, it's super strange. It's like the stuff isn't even in the field of view anymore. I just don't know how that's possible. I guess we should just fucking write down the transform. Final transform. Okay. This is like impossible to read, but can we just close this and look? So final transform is 0 change, x is basically the same. This is a lot like low values here, but surprisingly non-zero, which feels kind of strange. Can we like render this out a little bit more clearly? Does transform have like a print function that we can add to it? Transform 3D. Can we do like format? I know there's a way to do this, but I just don't remember what it is. Zig format. I guess he's gonna complain to us. Here we go. So can we look at this file? There we go. This is what I'm looking for. Okay. Okay, so we have our value. We say 4, 0 to 4. 4, 0 to 4. We say this is row index, call index. Row is value inner data from row index over 4 to row index plus 1 over 4. Simple. No, I'm wrong. Row index times 4. Here, that makes more sense. Const. And then we say, we write this thing out. So say writer print this thing given row at call index, okay. Then at the end of the row, we write a new line. And these things need to be tried, I think. And he's mad that we're not using some of this shit that we don't care about. So we'll just slap those like this. And then hopefully that we can like write this thing down in a way that's like visible to us now. Does this make a little bit more sense? It does. It does. Okay. What's happening here? How? This looks kind of fishy to me. This does not look right. Yeah, that looks kind of fucking wrong. Where's our, like, mat mall? I mean, we confirmed there are mat malls, right? Okay, what if we just fuck any... Fuck anything other than looking at, like, the transform. The perspective transform. We're not gonna take the camera position into account. We're literally just gonna draw the camera transform. So even that is fucked up. And that has this. Okay. So this makes sense. So if z is really far, this is if z is 10, this becomes -1. If z is 0, I mean, that's, like, kind of reasonable, I guess. So yeah, if we can like plug in z is 0.1 here, so he gets negative 0.1 minus 1 is negative 0.1 minus 1 is negative 1.1 over, yeah, that doesn't seem right. I don't think that's right. Negative 1 times 0.1 minus 1, negative 1.1, divided by negative 0.01 times 0.1. Okay, what if we get, like, z of... Okay, so this is supposed to go from negative 0.1 to 10. So we punch in 10 here. Negative 10 minus 1, negative 11, over negative 1, negative 12. Yeah, something about this doesn't feel right at all. This does not feel right at all. I feel like fucking mental, dude. Yeah, I feel mental. I feel, like, actually mental. And I know we've looked at this before, so it's just like, why can't my stupid little brain wrap my head around this? Is this supposed to be plus? Because, like, it's clearly wrong, or my expectations are wrong, and I can't place it. Can we just make, like, a fucking... I think it's time for us to fucking test some values. It's the only way. So anyway, so let's go into our mat 4x4 and do a pub function apply. He takes in a mat 4x4 and a vec. Oh, he already has it. Vec, we already have mul in here. Oh yeah, then let's just do that. Const perspective is equal to this. Okay. And can we just be like perspective mul 0, 0, 10, 1. Right? What do we get out of here? And then we need, like, a... We want to print the number of val 2 over val 3. Inner. Okay. So yeah, so 109, what if it's... Which is crazy, right? If our perspective transform is supposed to map ranges in the value of near, far, let's flip these, I guess, to the range 0 to 1. The fact that we punch in the far value here and it doesn't give us 1 is, like, a big indicator that we've done something fucking stupid. I just can't understand what it is. Okay, so I guess what we have to do is we have to figure out what they're trying to do here and figure it out of ourselves. So, like we've said this before, that we have to divide by z, right? That's kind of oh fuck, I know we've derived this, but I just feel like I shouldn't have to fucking derive it. Why should I have to fucking derive it if I have the fucking answer right here? It does the wrong thing. Why is it? Why I shouldn't have to derive it myself, man? I shouldn't. Okay. Let's also punch in. Let's just also punch in 0.1 here. 0.1. And see what we get. Are either sides mapping the way we would expect? No. These are insane values. These are insane. So is our mul correct here? We should double check that. 04, 48, H12, 12, 16, XYZW. Yeah, I mean, I don't see why not. Can we try, let's try applying this to like a scale, you know? Just to prove to ourselves that our matmul is doing what we expect it to do. So here we should see this number be 0.5, which it is, right? So it's not crazy. It's not crazy. I feel like, I mean, the fact that our perspective is just being completely fucked and it's not giving us the answers we expect seem reasonable to me. Okay. So we know that we need to divide by z as we get farther away. We also know that the z value has to map from 0 to 1. So we need some set of values that say at, near, go to 0, far, go to 1. That's what we're trying to do. So if we know that we're going to be dividing by far, right? Let's just say near is 0 to kind of make things simpler for ourselves. We'll set near to 0. So maybe we have maybe we can't do that. Okay, so this near minus far is the distance between the two. That makes sense. So we have, if we have near of 0.1, far of 1.0, near minus far is negative 0.9. Okay, so if we want so that we need to plug something in so that at the very far end, we want the farthest distance. Do we want that to go to 0? No, we don't. We want that to just have z values of 1.0, and we also, I'm sorry, my brain's not working right. We are trying to make it so that x and y, are you missing a minus in z2? We copied a graphics pipeline, this one. I don't, oh, this is the wrong one. We were looking at this one. Near times far over near minus far on both. No, I don't think so. I don't think so. We're trying to make it so that x and y get smaller as z gets bigger. Small as z gets big, right? Simple, very simple. We are trying to make, which means that z has to end up in the w component because everything is divided by w. So let's just start by putting 1.0 here, right? Simple. Now, if we were to do this, where there's basically we divide everything by z, that would make it so that z also gets smaller as z gets bigger, which is not, or that would make it so that z is always 1, right? So we put something else here. We want z to be 0 at near, right? So that probably explains one of these things. And z equals 1 at far. So if we plug in far here, yes, we plug in far here, we need this to be 1.0. We plug in near, it needs to be 0.0, which means that the value, that's what these z1 and z2 are supposed to be doing. Right. So that's why when you get near, you plug in near at the z value, you get near times far over near minus far over near times far over near minus far. Yes. Okay, that's a clue. But don't we want far times far? I feel like we almost want like this. So that when we plug in far, we get this. We get far times far over near minus far over far times far over near minus far. That makes sense. That makes 1.0 at the far end. Now, how do we get 0.0 at the close end? It's like you need to subtract. I almost want to say that you want like. Okay, this is how it makes sense in my mind. Okay, this is how it makes sense to me. So here you put in z1 here, z2 here, and so when you plug in near for z, never mind, this doesn't make sense. I was wrong. What is the negative 1.0 in their version doing? They're saying subtract near, essentially. So you plug in near. Oh no, this is just w. So you're inverting z, which we might not want. I feel like we're missing the condition here where when I plug in near here, I get 0. So how does that happen? We need to like you need to I don't know. Why don't I know? And why is this so hard? Yeah, I feel like they've done something backwards from what I want in these. So can we look up the other version of this thing? It's pissing me off that we've done this before and I just can't fucking remember. Okay, what this guy did, does his make more sense to me? So where does he get to his like field of view projections? No, none of these make more sense. Infinite perspective matrix. I'm gonna have to think it through it myself. I need to think through it myself. There's no other way. There's no other way. Row column, major column. We are inverting it already in OpenGL land, I'm pretty sure, but we should double check. Dude, I would be pretty pissed if that was the problem. Yeah, we do transpose it on input. We're handling that. I mean, I'm pretty convinced that this is wrong. I'm pretty convinced that like it's not behaving the way we want it to. Oh, unless you're saying that what we copied from Wikipedia was fucking column major. That would make a lot more sense, actually. That would make so much more fucking sense. Oh my god, that's it. That's it. Thank you. That makes so much more sense. Yeah. That actually, oh my god. Oh my god, I'm a dumbass. Okay. Now this makes sense, right? Because now what's happening is this near minus far on Z2 is offsetting when we punch in near here. We subtract near minus far from this thing. Right, okay. Yes, because that means that like the W value is 1, so we get this for W. This becomes subtracted. I also want to say this should be, this feels like it should be negative here. So we punch in near, we get near minus far, near minus over near minus far here. Then we subtract near minus far over near minus far, so we get 0. If we punch in far, we get far squared over near minus far for Z divided by 1.0. Let me think about that. So if we could just punch in the values here and check. Oh, okay, 6. We're getting -1 now when we punch in 10. And when we punch in 0.01, we should get 0. So that's really good. There's just a negative in here that shouldn't be there now, which is probably this one. So now we punch in 0.1 and we get -0. And then we punch in 10 here. And we should get +1. Yep, and then we punch in something in between. We get something in between. Holy shit, dude. Thank you for saying row major, column major. Oh my god. Or we should punch in 5.0, I guess. And we get something in between. That makes so much more sense. Okay, so now if we use this thing now and we actually look at the fucking output, still busted though. Still busted. But at least now this is making sense to me. When I apply this, when I do this math multiply, this vector multiply, it's giving me values I expect. Okay, so now the question is how do we get this shit to render in here? Well, we still need to move the camera backwards, right? So that was impressive. That was important. Not impressive. Important. So we want like the camera, born on camera, then perspective transform. Okay, still not quite right. Fuck. So, what now? What now? It could be that this negative at the bottom is... So why do they don't have this negative here? Which is a little concerning to me. What happens if we go back to writing down our things? Why don't they have the negative there is a question that we should be answering. So I punch in 10 here and I get 1. I punch in 0.01. And I get 2. Yeah, so it still seems like even by just like inverting it, we still seem confused. But I guess if our near and far swapped, no. I mean, this is what made sense to me. I guess we'll just go back to this, because this gave us the answers we were expecting. But now the question is why is it not giving us the behavior we're expecting in OpenGL? All right, I click this. Let's just double check again that we are applying our perspective with the camera matrix. Okay, and if we move backwards and forwards, do we start to see anything? Who knows? Let's find out. It doesn't feel like there's any... Oh, wait, what's this? What's this? That's definitely something. What if we just keep going? Wait, I mean, that's definitely something. Wait, 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 wait. What the fuck was that? What was that? What was that? Oh my god, we're here, we're here, we're here, we're here, we're here. It's here, baby! We made it! We made it! Now the question is are like one of our clipping planes is kind of fucked up, it feels like? Oh, do we have backface fucking culling on? No fucking way is it because we have backface culling on. Oh, that would piss me the fuck off. Or maybe our camera's looking backwards. That's also a very real possibility. We're so close, though. Yeah, I wonder if our camera is looking the wrong way. So we could check that by making, instead of moving our camera -1 here, if we move it 1 here. Okay, wait, hold on. So where are we actually seeing this stuff? It's like if we get like right inside it. Okay, so right now our camera is at like -5.4, -1. Okay, so this is -1 and we're looking this way. Okay. Wait, maybe this is just kind of right. Why am I... No, it really feels like... It feels like the near and far plane are like somehow like backwards from each other. I don't know how to like describe it. It's like we're looking backwards to the world. It just it feels like that. So can we look at like near like perspective? I just want to see if we do like negatives on both of these, like what happens. Doesn't seem to be doing anything. What if we did like 10.0, 0.01? It just feels like something about those things is like backwards. I can't really place it though. Aha. Aha! They were backwards. Oh, come the fuck on. Okay. We fucking made it, baby. We made it. We made it. Oh my god. It took like fucking forever. But now at least we can like start inspecting. Okay. There's definitely something wrong about the like the rotation of the camera as well. But fuck it. Rip timestamps today. That's true. Okay. Well, I was hoping to do way more than this. But I got fucking just stuck on that fucking camera transform again, dude. Every time. This is why I fucking need to get the reps in. So I think it's actually good that we did it this way because like I do just need to get the reps in to make it so that I'm used to that, but holy shit. All right. Well, thanks for watching, guys. A little bit of a disappointing stream, but it is what it is. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now. So if you are watching live, you should expect to see us between 3.5 hours ago and now. If you are watching live and you're like, I would like to keep up with your project, but it's fucking, I can't watch every day. There's a YouTube link in the Twitch description. Project is organized into playlists. We are working on this building map of my code, but there's other stuff if you want to check that out. Code for this will eventually end up under code map, probably under a different form, but the code repo is up there. I throw my stuff out there in like a work in progress branch, but eventually it needs to get cleaned up. Yeah, I don't know. We'll call it there for today. Thanks for watching, guys. YouTube, peace out. Twitch, let's find someone to raid.